React. A popular open-source JavaScript library used by countless developers for building user interfaces of single-page applications. It was originally developed and is maintained by Facebook. The subject of React can be broadly broken down into four main sections: its architecture, structure of React applications, thinking in React, its working, and its ecosystem. Let's start with its architecture. React uses component-based architecture. React apps are made out of modular, reusable components that represent different parts of the UI, which has its own logic and appearance. The scale of a component can be as small as a button, or as large as an entire page. Components can be nested within one another, and based on component hierarchy and flow of data between any two components. A higher-level component is called parent component and a lower-level component is called child component. React components are JavaScript functions that return markup and encapsulate styles and behavior. Markup syntax used in components is called JSX. JSX is a syntax extension that allows you to write HTML-like code within JavaScript, used to describe UI elements. JSX lets you put markup into JavaScript. Curly braces let you escape back into JavaScript so that you can embed some variable from your code and display it to the user. You can also escape into JavaScript from JSX attributes, but you have to use curly braces instead of quotes. React follows the principle of unidirectional data flow, means data in React applications flows in one direction, from parent components to child components, which is done via props, short for properties. Props are read-only attributes, meaning immutable. Once set, they cannot be changed by the child component, and used to pass data and event handlers to child components. At this stage, React components are static and unable to respond to user interactions or changes within the application. To solve this problem, we need state. State is a built-in object that allows components to create and track their own data that may change over the life cycle of the component. State changes trigger re-renders, allowing the UI to reflect the current state. State is managed within the component itself, providing control over its data and behavior. To manage or update the state in functional components, we need hook called useState. Hooks are a very powerful tool in React, which are functions that let you hook into React state and lifecycle features from function components. Hooks like useState and useEffect allow you to add state and side effects to function components. There are 9 types of hooks in React, specialized for specific cases. First, state management. useState manages local state within a functional component. useReducer manages more complex state logic, often used as an alternative to useState. useSyncExternalStore subscribes to an external store with synchronous reads, typically used for state management libraries. Second, side effects and lifecycle. useEffect runs side effects after render, such as data fetching, subscriptions, or manually changing the DOM. useLayoutEffect runs side effects synchronously after all DOM mutations, used for measurements and mutations of the DOM. useInsertionEffect used for injecting styles into the DOM, designed to run before mutations are flushed. Third, context. useContext accesses the value of a React context. Fourth, performance optimization. useMemo memoizes a computed value to optimize performance by avoiding expensive calculations on every render. useCallback memoizes a function to optimize performance by preventing unnecessary recreations of functions on every render. Fifth, unique identifiers. useID generates a unique ID that is stable across renders. Sixth, general catch-all. Use general-purpose hook, often seen in experimental or new API contexts. Seventh, concurrent features. useTransition defers state updates to avoid blocking the user interface. useDeferred value defers a value that might be computationally expensive to calculate, useful for non-urgent updates. Eighth, forms. useFormStatus manages the status of a form, such as submitting, succeeded, or failed. Use form state manages the state of form inputs and validations. Use optimistic handles optimistic updates for forms, updating the UI before the server confirms the change. 9th. Refs and imperative handles. Use ref creates a mutable object which persists for the lifetime of the component. Use imperative handle customizes the instance value that is exposed when using ref in a parent component. Thinking in React. A methodical way to build React UI consists of 5 steps. 1. Break the UI into a component hierarchy. The first step is to break down the UI into a component hierarchy. This involves identifying the distinct parts of the interface and mapping them to components. 2. Build a static version in React. Once the component hierarchy is established, the next step is to build a static version of the UI in React. This involves creating the components and rendering them with static data. At this stage, focus on the layout and structure without adding any interactivity or state management. 3. Identify the minimal, but complete, representation of UI state. To add interactivity, it's essential to identify the minimal set of mutable state that the application needs. 4. Identify where your state should live. Determine which components should own the state. According to the React documentation, state should be owned by the component that renders something based on that state. Needs to pass the state down to its child components. 5. Add inverse data flow. Finally, add inverse data flow to make the components interactive. This involves passing callback functions from the stateful parent component to the stateless child components. The child components call these functions to update the state in the parent component. Some recurring patterns that every React developer should know are conditional rendering and rendering lists. But how all of this works under the hood? To understand this, we need to understand what the DOM, Document Object Model, is. The DOM represents what you see on your screen when you open a website, expressed through the markup language HTML. Then we have the virtual DOM, or VDOM, which is a core concept of React. The virtual DOM is an in-memory representation of the actual DOM. It consists of your React application's elements. When a React component state changes, React re-renders the component and generates a new virtual DOM tree that represents the updated UI. React compares it to a previous snapshot of the VDOM, and then only applies the minimum number of operations necessary to update the actual DOM to match the new virtual DOM. This process of comparing the old VDOM with the new one is called reconciliation or diffing. Reconciliation process uses an algorithm called Fiber. Fiber is the reconciliation engine in React that enables incremental rendering. This means that React can now perform work on the virtual DOM in smaller, more granular chunks, allowing it to better prioritize updates and provide a smoother user experience. React also employs techniques like batching and scheduling to further optimize the update process. Batching means that React groups multiple state updates together and applies them to the DOM in a single operation. Scheduling allows React to prioritize updates and defer less important ones to improve perceived performance. React itself is a powerful tool for building user interfaces, but the real power comes from the rich ecosystem that has developed around it. Like for routing, we have React Router and Next.js. For designing UI, we have UI components like Material UI, Ent Design and Chakra UI. Next, for styling, we have Sass, Emotion and Styled components. For state management, there are tools like Redux, React Query, and MobX. To help developers, we have developer tools like Cypress, Storybook, and React Developer Tools. Next, for data fetching, we have Axios. Another complex task like doing server-side rendering, tools like Next.js and Gatsby are available. For internationalization, there are React INTL and I18 Next. Likewise, after development for testing, we have Jest, Enzyme, and React Testing Library. For mobile development, there are tools like React Native and Expo. And also the increasing adoption of TypeScript in the React ecosystem has led to better tooling, improved developer experience, and more robust applications.